Hello. Now we will calculate the electric field due to dipole along the perpendicular bisector of this dipole. So this is my dipole, minus q plus q. The dipole moment is P, obviously from minus 2 plus the value of P. Magnitude wise it is 2 times of QL. Okay. And we want to calculate the electric field at point P, which is at a distance x with respect to the center of dipole. This is point O. And this point P is along the perpendicular bisector of this dipole. Okay. So we will be calculating the field first due to individual charged particles, and then we will be taking the vector summation of those two electric fields. Okay. So before that, let's join point P with these charged particles. Now, due to point Q, due to this charged particle, I'm calling this 1 and this as 2. Due to charged particle 1, the electric field at point P will be along the charged particle. Obviously, this is E1 in this direction. Now, due to this Q, the electric field will be away from Q. Again, the line joining P and Q in this direction, E2. Since these distances, if you talk about these distances are same, and the value of this distance, the distance between charge and the point P is under root of x square plus L square, because this distance is L as well as this distance is also L. Same is this distance. Okay. Now we'll be calculating the E1 and E2 separately, and we'll be taking the resultant of those two. The magnitude wise E1 and E2 will be same because the magnitude wise charges are same and their distance from point P is also same. So let's write the value of E1, which is same for the E2 as well. So 1 upon 4 pi epsilon naught, and the magnitude of charge is Q divided by distance square of the distance. So square of the distance is x square plus L square. And if you do the square of that, it will be x square plus L square. So this is the magnitude of electric field. Okay. Now, in this case, we are always go by this relationship because the x is very large compared to L. So let's take x common here. So 1 upon 4 pi epsilon naught Q upon x square. I'm taking x common here. And there remains 1 plus L square upon 2x square. Okay. This is your E1 as well as E2. This is your equation 1. Now let's see this E1 and E2. If you take the vector summation, it's better to take the components first. So if this angle is theta, this angle will also be theta. And since these two angles are same, this is the angle theta, same angle theta, as well as this angle theta will be same. So if I take the component of E2, it will be E2 sine theta in vertical direction and E2 cos theta along the horizontal. And if you talk about E1, it will be E1 sine theta in vertically downward direction and E1 cos theta in horizontal direction. So if we add all these four components of electric field, you see this E2 sine theta and this E1 sine theta, magnitude wise E1 and E2 is same, and both are having sine theta. So one is in upward direction, one is in downward direction. So these two components are going to cancel each other. So when you are going to take the resultant of E1 and E2, the resultant will be E1 cos theta and plus E2 cos theta, because both are in the same direction. So net electric field at point P will be E1 cos theta plus E2 cos theta. If we write the value of that, since E1 and E2 both are same, so it will be 2 times of 1 upon 4 pi epsilon naught, that's the value, Q upon x square plus L square multiplied with cos theta. Okay, this cos theta, this is the theta. If you take cos theta, it will be based upon hypotenuse. So it will be L upon under root of x square plus L square. And that will become 1 upon 4 pi epsilon naught 2QL x square plus L square power 3 by 2, because 1 is there and 1 by 2 will come from here. Okay. This is net electric field at point P. Let's do the little bit rearrangement. So what I'll do, 1 upon 4 pi epsilon naught. This is 2ql. 2ql becomes p, magnitude wise. And I'll take x common from here. If I take x common, it will become x cube. And that is 1 plus L square upon x square power 3 by 2. Now you see, since this L is very small compared to x, so L square upon x square, we can say it is tending towards 0. Based upon that, 1 plus L square upon x square, we can say it is tending towards 1. So the net electric field at point P will become 1 upon 4 pi epsilon naught P upon x cube. This whole value will become 1. So this is the net electric field at point P. So this is the magnitude of that. And the direction, if you see, direction of P is from minus q to plus q. It's in this direction. The electric field is coming in this direction. So electric field in this case is anti-parallel to the P. So if I want the vector formula for electric field at point P, that will become EP is equals to minus of 1 upon 4 pi epsilon naught P upon x cube. Okay. So this is the electric field along the perpendicular bisector. This is the electric field along the perpendicular bisector of this dipole. So now we have two formulas. We have electric field along the axial axis and we have electric field along the perpendicular bisector as well. So these are the formulas. One has to memorize these formulas. My suggestion will be, don't use this one, use this one. Because many a time, whenever you need to show the direction, it's very easy to get the direction in the question itself. Okay, so there will be less chance for doing any silly mistakes. Okay, thank you.